Eric, you can introduce, of course.
So, human exploration, robotic exploration of the universe call for very long journeys, months, years, far from the Earth, far from the Earth's infrastructure, in a harsh and hostile environment, and with round-trip communication between the spacecraft and Earth, which is very long. And as Jean was explaining in introduction, in this kind of complex environment, we cannot cope with late or wrong decisions. So, should it be for deciding the landing site for Mars rover during the descent phase? Should it be to assist the astronauts during their stay in a moon village or in the space station? Or should it be for securing the trip of a human being to Mars in the years to come? We feel that artificial intelligence can play a role in assisting the people, in assisting the machine to provide educated information or suggestions for decision. So we are very pleased to welcome Nicole Rosi with us. Nicole is leading the AI activity at European Space Agency in the Human and Robotic Exploration Directorate. She already has a great level of experience in artificial intelligence, and she will explain us how AI is part of Terra Nova, the ESA, European Space Agency program for exploration for the 15 years to come. Nicole, the floor is yours.
Thank you very much, Eric. Hi and good afternoon to everyone. I'm Nicole Rosi. I work both on artificial intelligence and quantum technology in the section for software and artificial intelligence in the Directorate of Human and Robotic Exploration. And today I want to give you a talk about how we plan to integrate and which in our opinion are a priority regarding AI use cases for space exploration. So I would like to start presenting you Explore 2040, which is the European exploration strategy, which is a strategy in response to the Terra Nova European Exploration Program, and it set the clear mission and actionable steps in order to reach long-term European space exploration objectives. Explore 2040, it was established upon agreement of 22 ESA member states, and it aimed to provide for a continuous, sustainable, and responsible exploration of the solar system with three main objectives. So its first objective is a European sustained presence in low Earth orbit. The second objective is to substantially participate in the NASA Artemis program with the purpose of having a first European human presence on the moon during the 2030s. And the third objective is de-risk the Martian environment in view of having first human presence on Mars beyond the 2040s. Explore 2040 is part of the Terra Nova European Exploration Program, which set the European values underlying space exploration. In particular, we are speaking about the value for scientific discovery, the value for economic growth, international collaboration, and inspiration and creation of intellectual property. Additionally, Terra Nova program naturally embodies the quest for the discovery of new technologies that can support space exploration, and it comes natural that artificial intelligence will play a leading role in revolutionizing many aspects of these activities. However, artificial intelligence is a quite broad term that often doesn't come with very broad confines. So in human and robotic exploration, we don't only look at artificial intelligence, but also at other arising technologies which can be integrated with the use of AI. In particular, we are speaking about extended and virtual reality, quantum computing, and robotic automation in particular. So now I will fastly go through the last three of our pillars, and then I will focus on artificial intelligence showcases. Extended and virtual reality is a technology that allows to have immersive experiences in an environment which can be 100% simulated, or they can present a layer of simulation and a layer of interaction with the surroundings, for example, through the aid of joysticks. Then we have quantum computing, which is an arising computational paradigm grounded in quantum physics, which exploit principles such as entanglement and superposition. And it is promising for specific computational problems, such as large simulation problems with very complex parameter space, or material and chemistry simulations. So quantum technology, quantum computing in particular, on the hardware side, doesn't have a TRL which is ready for a real-world application. However, we are mainly looking at this technology and monitoring it for the future. On the other hand, robotics is a quite well-established field. However, we are interested in this case in looking how AI and robotics can be integrated together in order to maximize automation, which is particularly important in space exploration. Now we can go and touch our three main destinations, LEO, the Moon, and Mars, and see which are the showcases that, in our opinion, are the most important to integrate upon what was already been established within our exploration strategy. As we know, every mission starts on Earth, and they already mentioned the importance of XR and VR. XR and VR is important in particular for training the robotic asset and astronaut, because it can provide with environments which wouldn't be reachable otherwise. And we also asked ourselves how artificial intelligence can support XR and VR, coming to the conclusion that in particular generative AI can be suitable to automate the production of 3D model or XR VR model, and it can also improve the accuracy whether we are able of implementing model that can use mission data or mission requirements as an input. It's also true that every mission ends on Earth with the production of terabyte and terabyte of many different kind of data, from images to sensor and scientific data. And in this case, we see the value of AI as a tool to extrapolate complex patterns from this data, as well as to fastly provide with relevant information. For example, using AI in the form of chatbot to support operators. Then we can fly to our first destination, which is the ISS, one of the most complex and larger spacecraft. And in this case, we are considering the use of AI to have it closer to the sensor in order to provide with augmented system for the detection or even prediction of failure, and to support during the isolation and recovery process of subsystems. As we fly to the Moon, the duration of the mission increases. Overall, if we think to the possibility of having a space station orbiting the Moon, gateway, or having again humans on the Moon. And in this case, we see the importance of developing intelligence crew assistant that can support the crew during all their activities. From planning and scheduling their activities to provide support during experiment and maintenance activities, as well as providing health, both physical and mental health monitoring. Another important activities within Explore 2040 that will be held on the Moon is in situ resource utilization, and in this case it is particularly important to be able to identify sites of interest, mapping them, so scouting and prospecting, and navigate to them. Another very important application will be the possibility to build on what is already existing for on-ground autonomous navigation system for this planet, which can tackle its specific challenges. As we go to Mars, even the communication becomes time critical, and so in this case, even though the specific applications are a little bit more blurred, the use of AI should go in the direction of automatizing as much as possible every possible action. I think a very nice example is the Perseverance rover that runs an onboard software to autonomously decide, based on the spectroscopy measurement, if a sample is interesting or not to collect without any communication with Earth. So I just went through many of the applications that we are looking into and that we would like to realize. However, there are some issues that dissociate us from making these ideas to come true. First of all, there is the need for robust physical and virtual data infrastructures and clearer data policies in order to have all the actors, to give to all the actors of a mission the possibility to access to a centralized data pool where they can safely and fastly access the relevant information. In many occasions, there is the need to translate the procedures into mathematical or logical models. In this case, I have another example. We often speak about creating automatic schedulers for astronaut activities. However, it may be pretty trivial for a human to create a schedule with activities that follow in order, which makes sense, but it's not clear how we can translate this thinking into a logical model that can be implemented. Once we will have all the model, there is also the need to translate this model into algorithms and integrate the algorithm with the proper hardware. And while we are on Earth, can be still a feasible and relatively feasible operation, but as we go to the moon or on Mars, we will meet many constraints which are related to power consumption, to radiation harness, as well as memory and computational constraints. Finally, we can also assume to have all these three pillars set up, but we will still need to find a way to validate and verify our software. And considering that we are thinking about putting in place a new computational paradigm, we will also need a new verification and validation paradigm that can cope with the specific weakness of artificial intelligence. And once we have this paradigm, to build the appropriate physical or numerical software validation solution in order to make our solutions flight ready. So this was the end of my talk. Just to summarize, I started to define which are the needs according to our Explorer 2040 space exploration strategy. Then I described which are the technology pillars that we aim to integrate within the strategy, to go through a series of AI showcases, and which are the main weakness right now that should also represent the R&D direction for the years to come. Thank you very much.
Thank you, Nicole. There is a question from the web. I read it. Say the Artemis 2 crew will have an Alexa interface in their Orion during their trip to Mars. From your point of view, how far can we go in AI autonomy in man-rated infrastructure? In man-rated infrastructures. I think it's human inhabited infrastructure.
Human
I think
inhabited.
So.
I think it really depends on it is really dependent on the specific case. Until you are, for example, on the ISS, you can still run your computation on ground. What is feasible on the Earth should be feasible there. There is already like a showcase of AI, Simon Chu, which was using a non-board, was computing its solution partially on board with the GPU and the CPU, but the model for natural language processing were running on Earth, on cloud. As you go far, it will depend on the specific case and the possibility to have mixed computational solution.
Yeah, the guy or the girl in charge of the question was quite, say, at the end he said, it is hardly needed anyway for Mars journey. For example, you don't need to put people in a cryogenic sleep and having AI taking care of the rest.
Yes, and I think when you see to Mars is quite hard to make prevision because this is like a panorama that also according the strategy will happen beyond the 2040s, and AI is developing quite at a fast pace right now. So it's like we don't only have to infer on which our tools now, but we also have to make a forecast on how this tool will change in the future.
Okay, thank you. We can applaud. I think it was a very impressive and let's say, going to the future already.